Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on EMC, electromagnetic compatibility. This video, I'd like to focus one of the EMC standard, which is EN 61000-4-11. Okay, so under this standard, we actually has three types of tests. The first one will be AC voltage dip. Okay, so which means that the power actually reduced by certain percentage. Next, we have this variation, which means that the power actually varies. And then last but not least, interruption, which means that the power actually cut off for a very short time. So basically, this video, I'm going to explain why we need to have this testing before we can so-called start to sell this product in the market, especially for the Europe. Okay, so basically this will be the objective of this video. Guys, if you're keen to know more about EMC, please see the playlist under the description. Over there, you will be able to find a series of discussion on EMC. This is my email. If you have any question regards on this discussion, please drop me an email, okay? Or if not, I actually prefer you guys to ask me your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Guys, just a few seconds, help me press the like button now. For those who are new to this channel, and if you want to encourage me, please consider to subscribe to this channel and turn on your notification bell. Once again, thank you so much for strong support. These are all the tests that you actually require to do when you actually build a new consumer electronic product. I have so-called actually discussed this under the EMC Part 45 series discussion. For example, when you actually has this new consumer electronic product, you can see that these are all the various tests that you need to do. Okay, so for the CE or the FCC standard. Okay, so from here you can see that clearly there are actually four types of tests. First one, let's focus on the radiate emission. Okay, so basically you can see that under this radiate emission, we need to do according to the EU standard and also to the FCC standard. Okay, so basically there are slight difference between these two standards, but you need to compliant so-called under their so-called specification, then you can quantify this product actually pass the EMC. So this is one of the tests, which is the radiate emission. Okay, so another one will be the radiate immunity. Okay, so radiate means that the so-called happening is actually through the air, as you can see from here. This actually tests how robust your design is under this radiate immunity. So from here you can see that we have this far field, okay, which is 61000-4-3 standard, and also the RF near field test, same as for this magnetic coupling test, which is 61000-4-8. Okay, so this is under the radiate immunity. So next, I'm going to introduce the conducted form of test. So from here, you can see that there are actually two types of cable that actually serve your EUT. One is actually the AC power. The other one is basically the IO port. Okay, so from here, you can see that, okay, for AC test, it actually require to do more tests, as you can see from here. But let's say if yours is just the IO port, so there is not so many tests that you need to do. For example, over here, let's say we consider this conductor emission. You can see that for this conductor emission, okay, only for Europe, then you need to do some form of testing. But you can see from this AC main, okay, you can see that for Europe, you have so-called to do a test, same for FCC. But over here, you see that FCC don't require you to do any form of testing on the IO port over here. So when you actually take a look on this conductor immunity here, okay, so basically you can see that for IO, okay, you can see that I actually just need to do these two tests, okay, which is the conductor immunity test and also the burst EFT test on the IO port. But for this AC main, okay, you can see that I need to do more tests. For example, this conductor immunity and this burst, they are the same. Okay, so these two tests you are actually required to do for any cable that serve your product. But over here, you can see that this is a so-called AC main. So you can see that I actually need to do some form of search. And today, I actually want to emphasize on this test, okay, which is the AC voltage dip variation and the interrupt test. And over here, you can see that I also need to do the harmonics and flicker test under this AC main port over here. Okay, so beside that, the last test is actually on the ESD, okay, which is the electrostatic discharge. Okay, so these are all the EMC tests that you actually require to do before you can certify that your DUT actually passed the EMC test. Okay, but you can see over here, okay, so you can see that Europe is actually more stringent. Okay, but for FCC, okay, it is less stringent for doing all the tests. Next, as I mentioned, I'm going to focus on EN61000-4-11. Okay, so what does this test actually do? So imagine this. Okay, basically this test actually so-called is how well will my device actually handle real-world power problems like brownout or blackout. Okay, so basically these are the tests that I'm going to do. So this standard, okay, basically will be handling the real world problem, okay, because this is going to fit to a power supply. So under the real world problem, you probably will have some form of blackout or a brownout or blackout. So therefore, you need to have this form of test. Okay, so basically this standard, okay, which is the 61000-4-11, they actually assist to answer this question by providing a test method for a device immunity to voltage dip, short interruption, and voltage variation. Okay, so basically, this is the test that I'm going to focus for this video. Okay, so why we need to do this test? Okay, basically, you know that this is for the power field AC. Okay, you can see over here. Okay, so this part is actually where the AC. Okay, so it may be slightly different, but just imagine this. Okay, so these are for the AC, and the AC may fail anytime, or the so-called the signal that they actually send out, also the power that they actually send out, they are not so clean. So-called they are not so clean. So therefore, this electrical and electronics equipment, they can be affected by voltage dip, okay, which means that the voltage is not that consistent. There may be some form of dip, which means that, let's say, they reduce certain amount of voltage. So therefore, we know this as voltage dip. We also have this short interruption, okay, which means that completely cut off the power supply, or some form of voltage variation. Imagine this. Let's say in Singapore, we have this 230 volt. Okay, there is a possibility that it may not be consistent 230 volt. It may go up and may go down. So therefore, okay, this is the issue on this here. So this voltage dip and short interruption actually occur due to faults in a network or in installation by sudden change of large load. Okay, so imagine this. Okay, because sudden so-called change in terms of the user. Okay, so this may cause voltage dip issue and short interruption issue. Okay, so in certain case, two or more consecutive dips or interruption can actually occur. As for voltage variation, these are normally caused by continuous very loads connected to the network. Okay, which means that the number of devices that actually connect to the network, they keep on changing. So therefore, this actually cause a voltage variation. As for earlier on, I did mention is basically this is caused by sudden change of large load. For example, you on and off a very large load. So when you actually do on and off, this may cause some voltage dip, or in some time you actually can have some short interruption. Okay, so basically this test here, we need to ensure that your DUT actually can survive all these kind of different variation provided by the generator, be it the voltage dip, be it the short interruption, or be it the voltage variation. We need to ensure that your DUT can still function normally. Okay, so basically this is why we need to do this test. Okay, so let me quickly explain, okay, what is the purpose of doing these tests and what are the scope of doing these tests. Okay, the standard, okay, does not set a pass or fail criteria. Okay, which means that, let's say when there's an interruption, okay, let's say your DUT actually cannot survive. Okay, so there is no criteria that say that it will pass or it will fail. Okay, so basically this is what I mean. Or when the voltage actually dip, okay, let's say your DUT do a reset. Okay, so there is no standard say that you can pass this test or you fail this test. Or another so-called condition is basically your power actually vary. So again, if your DUT cannot survive and properly do a reset, so again, there are no pass or fail criteria. So instead, okay, it actually provide a consistent and repeatable procedure for testing a device immunity. Okay, so in short, this standard, there is no consider any form of pass or fail. Why we have this standard is to provide a very consistent, something that is actually repeatable, so that to test your device immunity. So for example, when you actually test it in this test house, it fail, it will continue to fail when you actually go to another test house. So basically, this is the objective of this video. So whether is it pass or is it fail the test is actually by you as a manufacturer. Okay, so the manufacturer or the test lab then define the acceptance criteria. Okay, for example, okay, the device must not turn off. Okay, because some of the device actually cannot turn off. Once it turn off, it may have some severe effect. For example, a pacemaker. Okay, so if the device actually turn off, then it may have not so-called pass the test, because those pacemaker, they must not turn off at any condition. So therefore, for some critical device, they are actually not required to turn off at all times. So next, they must not malfunction. Okay, so for some case here, okay, the device may turn off, the device may reset, okay, but the key thing is it must not malfunction, which means that when you actually do a reset, it must be able to so-called go back to the original state and operate normally. So next, okay, will be the must recover automatically, which means that let's say if you have this voltage dip, okay, although it will do a reset, okay, you must ensure that the thing will recover automatically, which means that you don't need to do any so-called intervention to make the device working. Okay, so basically this is the purpose and the scope. Okay, so from here you can see that there are actually three types of tests. Interruption, a very short time without the power. Voltage dip, which means that at certain level, the voltage actually drop. This voltage variation, okay, you can see from here, you have certain percentage of variation, okay, that is actually supplied to your DUT, and you must see whether your DUT can survive this kind of voltage variation or power variation. So next, what phenomenon does it actually cover? Okay, the standard break down the power quality issue into three main categories. As I mentioned earlier on, voltage dip, short interruption, and voltage variation. Okay, so under this voltage dip, okay, basically it will be a very quick, sudden, okay, very quick interval, short-term reduction, okay, in the RMS voltage level. Okay, so think of this as a brownout. Okay, for example, okay, when a large motor actually start up nearby, okay, it can monetarily drag down the local grid voltage. So basically, imagine you have a very large motor when they actually just start. Okay, so basically all those devices using the same source of generator, okay, they will be dragged down, okay, because the local grid voltage actually reduced, so therefore all the device also will be affected. Next, on the short interruption, okay, so basically it will be a very brief, completely loss of voltage, which means that totally zero voltage. So this is like a blink, okay, in the power, okay, a quick blink in the power. So this is often caused by the utility companies that are actually switching the circuit or clearing a fault. Okay, so that's why we need to have a short interruption. Next will be the voltage variation, a very slower and more gradual change in the RMS voltage, as you can see from my previous slide. Okay, so it won't be anything go all the way to zero. Okay, so basically the changes will be gradually. Okay, so typically it's used to simulate the condition at the end of a long power line or in a heavily loaded network. Okay, so basically from here you can see that they actually prepare your DUT to survive under this kind of so-called constraint, be it the voltage dip, be it the short interruption, or the voltage variation. Your DUT actually need to survive this form of test. Next, coming to the key test parameters here. So you can see from here, there are mainly four types of key test parameters here. The core of the standard is actually a table of test level that actually combine certain percentage of voltage reduction with a duration. Okay, so basically you can see that with a duration. Not all levels are tested. The appropriate one are chosen based on the product intent environment. Okay, so which means that you don't need to test all. Okay, so basically you must know which one to test. Okay, so on my next video, I will do a deep dive. How can we actually do this test? Okay, which is the AC voltage dip, variation, and interrupt. Okay, but for now, okay, just need to know that there are actually four different types of test level. Okay, you can see that they are properly in terms of voltage reduction. They also control the so-called the downtime and what will be the typical real world cost. Okay, so basically this, as I mentioned, on my next video, I will do a deeper discussion how to determine which test for you to do for different product. Okay, so I will leave this discussion on my next video. Next, okay, so important notes, okay, because there will be some confusion. Okay, for example, some 70% reduction. What does 70% reduction means? Okay, so basically a 70% test level means that the voltage is reduced by 70%, not reduced by 30%, which somebody thought. So which means that when we actually have this 70% test level means that the voltage is actually reduced by 70%, leaving only 30% of the nominal voltage. So this is actually a very common point of confusion. Okay, so basically a lot of people are not aware. They thought that they basically just reduced by 30% rather than 70%. Okay, so basically it's another way. So next is on the duration. Okay, the durations are mainly specified in both cycles. So basically our device is either at 50 hertz or 60 hertz. Okay, so you need to specify this. And in terms of times, okay, it can be millisecond or second. Okay, for example, one cycle at 50 hertz is actually 20 millisecond. Okay, so again, on my next video, I will do a deep dive on all these criteria so that you know how to set your different tests in order to ensure that your DUT actually compliant to the test standard. Last but not least, in terms of the phase angle, okay, so the standard also specified that dips and interrupts should be applied at different phase angle of the AC waveform. Okay, so basically, you know the AC waveform basically like a sine wave. So they actually has different phase angle. Okay, for example, we need to do the test at 0, 45, 90 degree, etc. So as the effect on the equipment can vary, actually they depend on when the events actually occur. Okay, so this is actually for the important notes. So guys, before I go into a quick discussion, how the test procedure on this AC voltage dip variation and interruption, I hope you can help me. If you have learned something from this video, I hope you can help me by like this video. Guys, just help me press the like button. Okay, so when you actually press the like button, this video will have a better chances to reach out to a larger audience. So guys, help me press the like button now. Again, urge you, if you benefit from this video, urge you to support me by subscribing to this channel and turn on your notification bell. Once again, thank you so much for strong support. Let me continue, okay, on the test process on the AC voltage dip variation and interruption. Okay, I will do a very general one, okay, but like I mentioned, I will also do a more specific one with the so-called with the diagram so that you will be able to understand all the test process. But over here, I just want to quickly discuss on the test process. Okay, coming to the setup, the DUT is actually set up in the normal operating mode. Okay, so basically you cannot turn off your device, for example. Okay, a lot of people actually thought that they can actually turn off the device when they actually do this test. But okay, the actual test is your device must be under this normal operation mode. Okay, so basically this is the test setup. Next, on the test generator, okay, so basically it will be a very specialized instrument. Okay, so for dips and interrupt generator, basically they are placed between the power source and the EUT. Okay, so this generator can precisely create the voltage disturbance defined in the standard. Okay, so basically you can see that, okay, they basically generate some form of voltage disturbance, and then they basically will go and disturb your DUT. And what you need to do is you just need to see whether your DUT can survive this kind of disturbance and all. So coming to the application, okay, we have this predefined test level. Okay, so again, all this I will mention on my next video. Okay, for example, there will be 70% dip for 500 millisecond. Okay, you can see that the time is very, very short interval. Okay, so they are actually applied to the EUT power input, and you just want to see whether can they pass the test and all. So what you need to do is, like for example, I mentioned you need to do some form of monitoring, okay, the EUT performance. Okay, so you need to closely observe, okay, during and after each test. Okay, so basically you must check whether there is any unexpected resetting or shutdown. Okay, so basically some of the device, when there is actually a so-called a disturbance, okay, it may go into resetting mode or shut down by itself. Okay, so some tests, some electronics component actually allow this, okay, but is for you to determine whether is this acceptable or not. So next, let's say there are some form of communication. Okay, you must see that whether the data actually will be corrupted or all the data will be lost. Okay, so for example, a wireless router. Okay, so for Wi-Fi. Okay, so basically when the data actually corrupted, okay, basically it will be not able to pass the test, right? So because all the data will be so-called garbage, because the data already corrupted or the link okay, actually lost, then it may not be able to do his intent task. Next will be the functionary error, okay, which means that let's say printer, okay, so it may not be so-called print at the correct thing, garbage come out again. So basically everything all go chaos. So this is what it means. In terms of the function, it cannot print anymore. Okay, so basically this is also some form of error. Next will be the failure to recover automatically. Okay, so some tests okay, actually so-called accept when the device actually so-called do a reset. For example, again, let me just share the printer. For example, your printer actually go down, okay, which means that they actually do a recover by itself, doing a reset. So if it's able to successfully recover by itself, you can actually quantify that this printer actually passed the test. Okay, because for printer, it's not that severe. Next, on the component damage, okay, for example, some capacitor will be broke. Okay, so because of this form of test, so you need to check whether there is any component damage or not. So coming to the evaluation, okay, based on the predefined performance criteria, the EUT behavior is classified under this normal performance, temporary degradation, or failure. Okay, so basically from here, okay, it doesn't mean that temporary degradation is so-called fail the test. For some device, they actually allow you to have some temporary degradation. Okay, so basically this is how we do in terms of the test process for the AC voltage dip, variation, and interrupt. Next, okay, why is EN 61000-4-11 very important? Firstly, okay, we need to ensure that the product is reliable. Okay, so this test actually ensure that the device can handle common power problems without fearing, leading to more robust and reliable products for consumer and industry. So next is basically just compliant. Okay, so for Europe, okay, basically they have this form of compliant. If you don't do this test, you cannot sell your product in Europe. So in short, this is for products sold in the Europe economy area. Okay, so therefore you need to demonstrate compliance with the EMC directive. Okay, often require testing against this standard so as to earn your CE mark. Okay, so basically this is by force, I will say that because it actually need you to compliant to this standard. Next, on the global relevancy. Okay, so while this is actually a Europe standard, okay, in principle are recognized and used worldwide. Okay, so it is only the Europe that actually adapt this international standard IEC 61000-4-11. So therefore, from here you can see that mainly I will say that it's by force. Okay, because under the Europe, they actually need you to pass this test before you can actually sell to Europe. So basically, this is why EN 61000-4-11 so important. Next, come to a very quick real world example. For example, a personal computer, okay, it should not crash or reboot okay, during a 200 millisecond voltage dip caused by an aircon turn on. Okay, so basically, this is just one of the so-called example to show it to you. Okay, for example, you build your DUT, okay, a computer. Okay, so you must ensure that it will not crash or reboot. Okay, when the voltage actually dip by 200 millisecond. So, so-called an industry PLC, okay, so it must continue to operate without losing its program during a brief power interruption while the factory backup generator actually start. Okay, so basically in short, over here you can see that okay, from time to time we may have some power interruption, but we need to ensure that okay, when the power actually has some form of interruption, you must ensure that okay, they will not lose the program. Okay, so they must wait a very short time while the factory backup generator actually take over. Okay, so we need to understand this as a real world example. Last but not least, a household LED lights. Okay, so it should not flicker excessively or turn off during a minor voltage variation. Okay, so basically this is under the voltage variation. We need to ensure that the light won't flicker. Okay, so basically you can see that some light actually flicker on and off excessively. Okay, so basically the light actually will be flickering. Okay, but our naked eye will not be able to see it. Okay, but over here you can see that you need to ensure that they does not flicker so excessively until you can see the difference or even turn off during this so-called voltage variation. Coming to my last slide, let me do a quick summary. So in essential, so this EN61000-4-11, they are actually a rule book for simulating bad power condition in a lab. So basically you can see from here, basically they just want to ensure that, for example, under the voltage dip, under the interruption, under the variation, etc., this is to ensure that whatever duty that you actually meet, they must be able to so-called to tahan, which means that to able to withstand this kind of disturbance. So basically by testing to this standard, manufacturer can design and verify that their products are resilient. So this will lead to a better user experience and fewer field failures that is actually caused by imperfection of the power grid. So from here, you can see that why we need to do this test EN61000-4-11, because in short, the power supply provided by the generator, they may not be clean continuously. For example, there may be some form of voltage dip. The value of the voltage, maybe they will be vary, and sometime when there is a switch over, we are going to have a very quick short interruption. We need to ensure that our DUT can still function normally. So basically, whether it pass or whether it fail the test is actually by you guys. When you as a manufacturer, some device like I mentioned earlier on, they actually so-called they actually allow for it to do a reset. As long as it can recover by itself, they actually certify this actually as passing this EN61000-4-11 test. With this, I'd like to end my discussion. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.